Okay, so today I'm going to be teaching you vertically launched projectiles at a certain height. Now, this is the final, I guess, topic for this lesson, which is projectile motion. So, I'm not even going to be giving a question or a sample problem because I'm just going to be using this picture so that you guys can see what it's actually about, and basically I'm just gonna be answering everything that we will try to do, or everything that is not given here. So as you can see, this is a combination of the previous topics I have explained to you. So we have here the vertical position, launched projectiles, which is here in this line. I'm gonna color that orange because you can see it clear. So it's like this. And then we also have the horizontal ones, which if this is the peak, imagine if we split this up, this would be the peak, which is 0, and it would start going down. So we're gonna box that as well. So now that we have this, we should also know where its actual peak is from the start, uh, between this area. So as you can see from the green line, we already have it, so we're gonna color that red, and we're also gonna be drawing a line all the way down to the ground. So, and then let's try to label everything as well. So we have VI here, and for here, which is 0, so VI, VF, VF, VI, and for the last one here, which is also VF and VF. Now we can color code these X, 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 then this one as well, Y, 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 and Y. So, this one's pretty easy. The peak, this is just 0 meters per second. And for the VFX and everything that is X, we will solve it. So, our given here is initial speed of 20 meters per second and a degree of 20. From the trigonometric functions, we will just be using Vi cos theta and Vi sine theta. So you already know this from the previous video if you saw it. Vi cosine is Vix, so we're just going to be 20 cosine 20 degrees. Yes, it's 20 degrees, which is 18.79. So I'll just write it like this. That is our Vix, and for our y, it's going to be 20 sine 20 degrees. Viy equals, let me put that in a calculator, 6.84 meters per second. So now we have the givens. Vix, basically all of these will always equal to the same 18.79. Then for the VIY, the one here, that is going to be 6.84. So I'll just write it down here on the left side, 6.84 meters per second. Okay, so the reason why this is a heavy lesson is because we are going to be, this is going to take a long time, but if you have mastered it, well, that's pretty good for you, because if you understand it, then it's actually pretty simple. So I'll be teaching you how to do this right now. Okay, so dy, we should also find first, or check first, what is missing. So VFY is also missing here, so we're just gonna question mark that because we don't know it. And of course, T is also missing. So our time is question mark. And negative 9.8 meters per second is obviously our standard or constant acceleration going downwards. Okay, so the missing here is dy and dx. Okay, so we're gonna be listing it down here. We're gonna draw a line from here to there. That is going to be our dx. And the red line here is going to be split into two because this is from dy1 and this is dy2, which we will only be solving this because dy1 is already given from the height of the cannonball, so cannon, so it's already 8 meters. Alright, whew, okay, you have to relax. Time to solve for time, right? Last topic, we used this as the time for the formula. Time equals VFY minus VIY. This is from the acceleration formula. If G is A and then you didn't have the Y here, it would be like this. It's very memorable, as you can see. But we can't use that because we don't know VF. We don't know. Yeah, we don't know VF. We don't know this part here specifically, and at the same time, this part specifically, if we were supposed to try to find time or split time into two from this part until this part. So it's basically impossible, and we can't use time symmetry because this is technically not equal to each other because of this whatever this is. It's not a equal parabolic curve path. Okay, so how are we supposed to do this? Now there are a few ways to answer this or to find time, but there's like a long way or a supposed shortcut where you can just split this into two parts, like what I did here. You can try to solve first this part, which is from the vertically launched projectiles on a level ground, and then add it to this part, supposing this is a peak and it's 0 meters per second, and also adding this to here. That will also give you time, but if it was supposed to be one equation, we would be using the quadratic formula. Okay, so the quadratic formula is basically negative b plus or minus, you know this, you know the drill. And we're gonna be using x as t, we're substituting x to t, a to g, our acceleration, b to 2 viy. The reason why it's 2 because it goes up and it goes down. And then 2 dy as well. So from the ground to the building, the dy, which is 8. So how are we going to translate this into projectile motion? So t here is going to be equal to 2 times negative, negative 2 actually, times 6.84 meters per second plus minus square root of 2 times 6.84 meters per second squared minus 4 negative 9.8 meters per second squared. That's the only for the unit. And then times 2, negative 2 negative 2 times 8 meters, and then divide all of this by 2 negative 9.8 meters per second squared. Now this would be perfect if you didn't need to solve or have a comprehensive solution. If you weren't supposed to solve everything inside first and then do it, because if you were to put this in a calculator, actually I'm not sure, I think this is supposed to be a positive number or a negative, but either way, I think it wouldn't matter. Yeah, it wouldn't matter actually. Let's just make that negative, because I'm pretty sure it's negative. And then if we were supposed to put that in a calculator, it would give us two answers basically, because there's a plus and minus sign here. So if we use negative number, if we use a minus sign, then our answer for that would be 2.15, which already we have the final answer. This is it. But if you use the positive number, it would actually give you a negative value, which is 0.76 seconds, negative 0.76. And as you know, when you're trying to solve for the quadratics, you should find the value that is positive, which is 2.15. That is our final answer. But if, let's say this is a negative value, then the answer for that would actually be this one. This would actually be the positive number, because it's going down, but in this case it's going up. So we will be using this. Now I must say I should actually try to break down this entire equation. So this is why this video is going to be long, but don't worry, I will be posting a simpler method, a different method for the next video. Alright, so let's start off with negative 2.684. I'll now be using the calculator this time. So 6.84, that would give us negative 13.68. Okay, so this is how you will be solving the quadratic equation in proper solution with a total uh, solution. So negative 13.68 plus minus square root of, now let's add, let's multiply all of these together. So here we already have, again, 13.68 meters per second, and then we're just going to square that, which is 187.1424. So that is the value. This is squared. Then for 4 times negative 8, so we will just, let's solve this first. So negative 2 times 8, 16, and then, whoops, negative 16, and then negative 9.8 meters. This is meters per second squared, then meters. So negative 9.8 times negative 16 is 156.8. So 156.8 negative 4 times that. Okay, so 13.68 meters per second plus minus 187.1424 meters per second, meters squared per second squared, and then 4, we would multiply it to here, so times minus 4, times 4 would give us 627.2. And then we will have to minus this one from this. Okay, hold on. This is also meters squared per second squared because it got multiplied. Okay. Now, I'm actually only focusing the top part first. I'm not gonna do this yet because it's going to be for the final. So we do this. Meters per second. Now 187.1. Wait, I just realized this is a, you can't square root a negative number, so I might actually be missing something here. Hold on. Okay, what am I doing wrong? Alright, this should actually be negative 6.627.2 meters. Because we're multiplying here. Okay, yeah. So that would be plus actually. So basically, I think we got this. 814.1424 squared. 114.24. 13.68. Let's disregard the units actually because it takes a very long time to put it. So negative 9 times 0.8 times 2 is negative 19.6. So now that we have this, we're going to solve for each value, which we're just going to be doing negative 13.68 plus square root of 814.1424 and 19.6, which should give us oops, I placed that in the calculator wrong. Hold on. Negative 0.75 or 76, which as you can see that's what we got. So negative 0.76 seconds. And then for the other time, we are going to use this again, but instead we use the negative value. Okay, so let me expound what I just did on the first number. So let's do this first here. So let me dot 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 dot. So 814.1424 over 19.6 here is equivalent to, let me put that also in a calculator. Negative 1.45 negative 1.455774525. Okay, ignore my horrible handwriting. I'm using a mouse. That's negative actually. It's minus. And then we just add that to, okay, hold on. You are actually supposed to do this first and, okay, yeah, hold on. Mess it up again. Okay, let me try to do that again. Let's not do that. Okay, I should have solved this first. I don't know what I'm doing. Negative 13.68 minus that, and then if you put that in the calculator, should give you negative 42.21. So negative 42.21318.068 divided by negative 19 2.6. And wait, if now minus that, I mean divide that, divided by 19.6, it should give us a total of 2.153733708, which is 2.15 seconds. And that's what we got. That is exactly what we got in our value here. So we will use this for the time formula. Okay, now that we have the time formula and I possibly explained it, hopefully, we're trying to find the dy next. Okay, now that we have time, I'll just put this here. Time equals 2.51. I mean 2.15. It's time to solve for d. Okay, let's solve for dx first because it's easier. So dx will also be Vix or Vfx times time. So this is why time is very important right now because it's basically in every equation. So all we have to do is dx equals the 18.79 meters per second times 2.15 seconds, which should give us 40.40. So dx is 40.40 meters. And for the dy, it should also be a simple equation. All we need to do is remember that vfy squared minus viy squared over 2g. This is also for kinematics, the 6 major formulas. So vfy is 0 squared minus viy is 6.84 meters per second squared over 2 to negative 9.8 meters per second squared. And then if we put that in a calculator, then it should give us 2.39. The dy equals 2.39 meters. Now wait, how is dy 2.39? What we just solved actually is this part, this dy, because we were already given dy1 here from the ground to the building. So this equation basically means that vfy, which is this one, the peak here is 0, minus the viy squared, which is here. We basically solved for this part, and then since it's negative 9.8 meters per second, that's why we try to solve for this. And to get the final dy, total dy I mean, is we just add it by 8, or the height of the building. So now we get 10.39 meters. Boom. So dy2 is 2.39 meters, and if we add all of them together, then dy is actually 10.39 meters, and dx here as well is 40.40. Now what is missing here? We have solved for almost everything except vfy, and for the final general vf, So we're gonna be using this formula still. We already solved this from the last video. So all we need to do is use this once again. So VFY is the angle of this, I think. Wait. DIY, we're gonna use 6.84, yes. 6.84 meters per second plus negative 9.8 meters per second squared times 2.15 seconds. And then if we put that in a calculator, we would get okay, hold on. I am pretty sure VIY here is 0. Yeah, wait. Okay, wait. We're supposed to find VIY from VFY here. So we're most likely going to be using 0. I mean 6.84. Let me just put that in the calculator real quick if I'm wrong. So what I got is negative 14.23 meters per second. So yeah, I'm pretty sure this is the right one. I'm not entirely sure because anyways, so now that we have the VFY here, it's time to solve for the general final velocity, which is this one, this formula. Whoops, could not find it. Now this was actually taken from the Pythagorean theorem, because if you look at this, we're pretty much finding the closest or fastest way from this destination, this location, to here. And that is going to be our general final velocity, which is the shortest one. Basically like finding the hypotenuse of the triangle. So VF equals square root of VIY squared plus VFY squared, or can be interchanged because oh wait, it's VIX. My bad. But yeah, it can be interchanged because you're adding it. VIX here is 18.79 squared. 18 squared plus VFY here is negative 14.23 meters per second squared. Now you should put this in parentheses because it will actually mess up when you put it in a calculator. So it would give you 202.4929 meters squared per second squared plus 18 points. D 30.0641 meters squared per second squared again, and then we square root that. All in all, it should give us final velocity of 23.57 meters per second, and that is our VF. Oh, we finally did it. I somehow try to explain it. Okay, it's not that tiring, so this is just the beginning. Hopefully you understand what this is. So basically what we just used are these formulas, which is just this and this. Alright, so we solved for everything. VFY here, we solved it, which is this. I'll put that there. So if you want to check if this is the right, if our calculations were right, as you can see, it is roughly the same as what I just did. So 2.15 is the time, 4.45 meters is the range, which is the dx, but ours is pretty close. There's just some problems with the rounding up. And then for our height, I will also take a screenshot, which is for our height here is 10.38 and ours is 10.39, which is close, which is also the same. And to check for VFY, I think you just need to check it by formula, but this is pretty much it. Now, I said that you can also have a different way of doing this and not just doing the quadratic formula. You can actually break it down, but I am not going to be showing you. You can actually try to solve this using the breakdown method. So all you need to do is find time here and find the other time here. You're going to be using two of the formulas, which is t equals square root of 2 dy over g, and for the top one you're going to be using t equals v f y minus v I y over g. Yeah, this one. And then you add both of these together to find the time, the total time. That is pretty much it. I also have a different way of doing this quadratic formula if you want an easier version of this actually. Something that can be mental math. It will only be in the next video, so I hope I can finish that as well. So yeah, if you want to see everything, here you go. Now I'm actually pretty sorry if there's some parts that I got wrong, but hopefully it's mostly correct. Alright, and for the cancellation, that I will leave that up to you, because hopefully you understand how to cancel now. So basically cancel these out because, you know, square root. But yeah, pretty much like that. Alright, see ya.